Namaste Friends, welcome back to the video learning series on web technology. We have been going through various aspects of JavaScript, why it is important, what facets it will add to the overall World Wide Web, how the dynamism and interactiveness it brings to the user, to the web overall experience. Then we went through various language specific aspects of JavaScript, some keywords and important rules, identifiers, literals, and so on and so forth. Then we went ahead and then looked at some logical constructs or the conditional constructs. Then last class we studied functions, how important the functions are and what kind of functions are possible. One of the key aspects of any programming language is its ability to manipulate strings. Why is it specially called out? Why is it not generally any other aspect of the language? We never say the same thing to math functions or any other library functions, but we always give a lot of importance to strings. In any programming language, JavaScript is no exception. The reason why strings are so important is because the strings have a direct relation with our world. In the sense, the problems that we try to solve in the programming world are the problems we actually see in real life, and then therefore we convert them into programming problems and then solve them. For example, if somebody wants to create a list of students who have topped the class, people have to parse through their names, which are strings. So names, strings, these are essential programming problems that need to be solved, and therefore any programming language that we choose must offer sufficient and decent enough support built into the language, either directly or through libraries, and then we always study them independently, in the sense specially. JavaScript has a decent amount of support for strings. It even has better support for regular expressions that we'll talk about in a moment. Strings are first class citizens in JavaScript, in the sense that each string is an object. Couple of things that we should be careful or we should be aware of strings in JavaScript are this. One, strings are mutable in JavaScript. The term mutable has a meaning, it cannot be changed. A string once created cannot be changed in JavaScript. Now, how do we replace some character in the middle? There may be some functions to do so. Yes, there are functions, but all of them create a new copy of the original string and return the new string to the caller. The original string is never modified. It cannot be modified. That is what it means to be a mutable string. This is similar, for example, in Java, where the strings are mutable there as well. In comparison, C, strings are not mutable. Strings are not immutable. They can be changed. The second important aspect of string is that because of its first class citizenship nature, some of the operators such as plus, the additional sign, can work directly on the strings. You can say string A is equal to string B plus string C. So the plus automatically amounts to concatenating the two strings, and a new string is created and is returned. The addition happens just like it happens on with the new numbers, with integers, or with floating point literals. The addition also happens in the same way on strings in JavaScript. But even here, we should be careful, or we should be aware that the original string is never modified, and a copy of the string is created and modified and is returned to the caller. Let's look at some important string operations that are possible in JavaScript. On the left hand side, in the next few slides, on the left hand side is a list of functions and a brief explanation of each function. On the right hand side is sample code illustrating those functions. These are all functions on strings, which mean they operate on a string object. You take the example of a string in line number 2, where s is equal to Rama in double quotes. So that obviously makes s to be a string. Now look at line number 5. The index of function is being operated on the string s. How do we know that? We are saying in the code in line number 5, s dot index of, which means the index of operation must happen on s, right? So this is what is the object string. In each of the descriptions, the strings on which the operations are performed are the are called the object strings. Okay, let's look at the example on the functions. The very first function is called char at. It is essentially, and it takes an integer as a parameter. The function returns the character at the specific index in the string. Take the example of a string Rama. Look at line number 5. Look at line number 8. We are saying what is the character at the index 2. Remember, in JavaScript, the indexes are 0 based, which means that index 2 is actually the third character. So what is the third character in the string Rama? M. Therefore, the j will have a value of m at the end of execution of line number 8. That is a char at function. The second function that is important is the concat function. Concatenation is similar to addition, just that there is a new function. We have look at line number 11. S is being concatenated with a new string which is passed as a value directly, and then the resultant string is stored in S1. Remember, S cannot be modified, so S remains intact, and a new string is created as a result of the concatenation of S and the supplied string, and the result is stored in the variable S1. Likewise, S1 is in turn being concatenated with another string Sita. So the resultant string is in S2. So S2 will have Rama and Sita after the two concatenation operations. This is the concatenation operation. You could easily do this with a plus operator. The third function that is important in this is the index of operation. It takes a string as a parameter and tries to look at the original string and tries to find whether the supplied string is actually somewhere as a part of the original string. Take a look at the example in line number 5. We are trying to find a string A in the original string S. Do we have A in the original string? Yes. So in case there is a string, in case the match is found, then the index of that particular substring is returned to the caller. In this case, I will have a value of 1 because 1 is the index of A in the string Rama. Now, are not there two Ramas? Are not there two A's in the string Rama? Yes, but the index of returns the index of the first substring that is found in the search. There is a last index of function as well, in case you want to look from the reverse direction, but they are similar. The index of returns the first index of the supplied string in the object string. So we have covered 3 functions in this slide. There are 3 more we covered now. These should be relatively simpler. The two lowercase function operates on a string, converts the object to lowercase and returns the new converted string. Two uppercase acts the opposite. It converts the string to uppercase and returns the converted string. And the trim function, it removes all the leading and trailing whitespace characters and returns the new string. Keep remembering, whenever we say returns the new string, it is essentially indicating that the strings cannot be changed and therefore the new strings are being created and returned. Is that a performance problem? It is. Therefore, we have to be careful in terms of how many objects that we keep creating and deleting in any other programming languages. There is one important library function called slice. Okay, this slice essentially try to create a substring or create a new string from within the object string. Consider the example in line number 2. The string S has a value Rama killed Ravana. The new let's say we want to extract some characters from this string and we know their indices. Then we will be using the slice function to achieve the desired result. Slice takes two parameters. One is the beginning index and the other is an ending index. This slice will essentially create a new string with characters from the beginning index of the object string and up to the ending index of the object string. Take the example in line number 5. We are doing a slice between beginning index is 0, ending index is 4. Because the beginning index is 4, we are starting with the very first letter R. Ending index is 4, so that is the white space. Now, will the result string include the first white space? The answer is no. The reason is the character at the ending index is not considered for the slicing. So we use just 4 letters RAMA. So as a result of operation slice in line number 5, S1 will have Rama. Likewise, we can include more and more by changing the beginning index and the ending index. There are a few more examples that are given. Key thing here to be noted is in the result string, the beginning index of the original string is used. That is where it starts, so it is included. The ending index is excluded in the result calculation. So that is something that we have to be aware of. So that they are the important functions that we need to be aware and we will be using as part of JavaScript as far as strings are concerned. Now, the next topic for us in this lesson is regular expression. Regular expression is a term that you must have heard quite a few number of times in other languages, especially if you have used Linux or any of the Unix based operating systems, or if you have ever used Vim or Emacs as a editor. What is a regular expression? A regular expression has two parts. One, it is a sequence of characters that form a search pattern, and it also has a set of search modifiers. So you now can guess that regular expression is really something that is used for searching, right? It has two parts. One, what to search, and second, how to search. But why is this so complicated? Aren't we doing searching every day? Why should it be given a new fancy name called regular expression? Is because they allow powerful searches. For example, you can do case insensitive searches. For example, you can say search for the string in this search for this particular sequence in this string, but ignore case. Or you can say search with a wildcard. What is a wildcard? Wildcard is something that matches anything. So in your match criteria or in your search pattern, you will say, for example, I want the first 3 letters to be RAM, but I don't care what is the 4th letter. Is there any such string? Is there any such sequence in my entire string? This is a very powerful way of searching, which is not otherwise possible without regular expressions. It can be used to do text searching as well as text replacement. We can find something and then replace. The syntax of a regular expression is there on the screen on the right hand side. As we said, there are two parts, pattern and modifier. A pattern is really a sequence of characters that forms a search. So this is really what to search for. Remember, this can have wildcards as well. We'll see that in the next slide. A modifier says how to search. It can be one or more special indicators that control the search. Now let's look at the patterns and modifiers. Patterns, if you have anything in square brackets, it means you are okay to find any of the characters within the square brackets. And if you give numbers in the square brackets, it means you are okay with any of finding match any of the digits. Or if you give a OR symbol, it means you want to find either X or Y or one of the two on the either side of the OR symbol. These are patterns. We'll see them in an example that probably should clarify a little bit. And then there are, in general, 3 modifiers. That is, if you say I, it means you want to do a search without any consideration to the case of the character. Global mode, it means that you don't stop searching at the first instance. You do search all instances. This is pretty useful if you are replacing. And then there is a third modifier M, which is for multi-line matching. Enough of theory. Let's look at some example and the function names. On the right hand side, you have an example where I have a string in line number 3, which is really some 3-line string. However, the term that I am very interested in has not been typed well. Sometimes it is typed with capital letters, sometimes it is typed with small letters, sometimes in the in between letters are capitalized, and so on and so forth. So this is a bad one. So what I want to do is, I want to see if that string Ramayana occurs anywhere in the string, right? Independent of the case. Do we have it or do we not have it? If we have it, then we'll replace that with a proper capitalization, which is capitalizing the first letter and changing everything to small letter. So to do this, we use 2 operations, search and then replace. On the left hand side, you have the syntax of these 2 operations. Search takes a regular expression and then returns the position of the match. If there is nothing that is found, a -1 is returned. Replace takes 2 parameters, a regular expression and a new string to be replaced. So any match for the regular expression will be replaced with the new string, that is the second parameter of the replace. Let's look at the example. Line number 5. I am defining exp1 to be my first regular expression. My pattern is Ramayana, but my modifier is I. It means I am looking to search for the string Ramayana with no consideration to the case. And then in line number 10, I execute the search using the search function on the string yes with a parameter regular exp1. So because the original string or the object string has the requisite substring that I am looking for, I will be 0 because that's the beginning of the that is there in the original string or the object string. So I will be 0, which is the index. Now that I found, I want to replace all occurrences of Ramayana independent of the case and replace it with the proper text, proper capitalized string, which is capital R and all other letters are small letters. So in line number 14, I am defining a new expression exp2. This has the same match criteria, same match pattern Ramayana, but there are two modifiers. The first modifier is I, which is for ignoring the case. The second modifier is G, which means that whatever operation that I am doing next on this pattern must happen for all occurrences, not just one. If we don't give G, only the first occurrence will be modified. If we give G, all occurrences are affected. And because we want all not well capitalized strings to be replaced, so we give G here. Line number 15, we are invoking the replace operation on the object string S with the pattern exp2, and we are asking it to replace all matches with the supplied Ramayana string, which is the second parameter. So after this string S, actually S2, because the string is not modified, the search happens and all occurrences are replaced with the proper capitalized word, and the new string is returned to the variable S2. So this is a simple example of a regular expression, how things can be used. This is especially useful for data validation and so on and so forth, which we will cover in one of our subsequent classes. So that's it for the class today. We went through a few important functions that can be used on strings, and then we also went through what regular expressions are and the kind of power it brings for searching and replacing. We also looked at an example that made use of a regular expression to do something that was otherwise not possible. I hope you enjoyed the lesson, and we'll see each other in our next class. Until then, thank you.